Alright, so there's some stuff I want to do programming, and I don't usually stream programming because I don't share the source code, and it's probably boring looking at only the user output perspective compared to looking at all the source code. But we're just gonna have to manage and make this a boring stream. And there's one thing I might want to look at is this remixer. Open. There's another screen that I don't show it here. Um, but on that one, the remixer, we choose a song. So let's do Kill Switch Engage Breathe Life. And this is the remix Breathe Life. It just randomizes the note and string fret length for each measure. It shuffles it around. But I don't like that logic because it makes it unplayable. Like if we look at right here, just go in the 10th fret. 10th fret. In other words, it might not be easy to play this. Wait, that doesn't seem like a remix. That seems like what it is. Hold on, let me open the original and see. So you go drop C. Well, how is this different? 565, 5600. This is the exact same. 575. Well, I guess I didn't do the remix. It's like the same notes. Can you imagine playing that at 200 BPM? Not gonna happen for me. Alright, so gonna change the remixer. You should see my source code. Wait, you can't. If you could though, it'd be crazy. So the idea down the line, if possible, is having PyTorch do that part. Having PyTorch uh do stuff. I got 3 screens. I need to go on ChatGPT because there's portions of this project I do use ChatGPT and there's portions that I don't. Stack Overflow Plus. Hello. I need to update my Python, PyCharm, PyGuitar Pro programming project. So currently I'm opening a Guitar Pro file and doing all my own logic to grab all the data. Every measure and every measure's notes, every measure's lengths, note lengths, strings and frets. And I'm grabbing that and adding it to a GUI format with Pygame, displaying it like Guitar Hero, moving the notation real time when the note should be played and all that stuff. It's fun. But the aspect I need to reach out for is bullshit stuff like fucking making this stuff work. I need to remix a song. I need to open a song. I have all the data of a song, and I need to add logic to remix a song. So I was thinking adding PyTorch library.
Hey Kyle the Guitar Man. That sounds like an incredibly fun and ambitious project. Mixing guitar profiles, real-time notation, and even remixing songs, that's a lot to take on. I'm thrilled to help you out with this. It seems like you're considering adding PyTorch to your project for the remixing part. PyTorch is a powerful deep learning library, and it could be used to create a neural network model to remix songs. Here's a general outline of how you might approach this. Pre-process the data. You'll need to convert the guitar profiles and other musical data into a format that can be fed into a neural network. This might involve extracting features like pitch, tempo, rhythm, etc. Create a model. You can design a neural network model that takes the pre-processed data as input and outputs a remixed version of the song. This could be a sequence-to-sequence model, a generative model, or something else depending on the exact nature of the remixing you want to do. Train the model. You'll need a dataset of original songs and their corresponding remixed versions to train the model. If you don't have this, you might need to create it yourself or find some other way to guide the training process. Integrate with your existing code. Once you have a trained model, you can integrate it with your existing code to remix songs on the fly. This might involve writing some code to handle the interaction between PyTorch and your existing logic for handling guitar profiles. Fine-tune and experiment. You'll likely need to spend some time experimenting with different model architectures, hyperparameters, and pre-processing techniques to get the remixing to work just the way you want it. Add a GUI, if needed. If you want to allow users to interact with the remixing process, you might need to add some GUI elements to handle things like adjusting remix parameters, previewing the
Alright, so I need to have the PyTorch implemented through my current process. What I mean is, I'm using PyGuitar Pro library, and I have my own logic to extract the data. I create a measure object, and the measure object has arrays for each note string, note fret, note length, as well as note string 2, fret 2, string 3, fret 3. So in other words, up to 1 to 3 notes per beat. Or in other words, I have all the information for this song inside of different arrays. And those arrays are what I use to, once again, build up another guitar profile. So I have all of the information. So what I need to do is pull the information from the song, which I already have the logic to do, put it into my format, which I already have. The PyTorch, I need to just take my current data of all of that information from the song, all the arrays of note lengths, notes, frets, note strings, for either one note or 3 notes, for every measure and every beat in the measure. I need to remix that data to make it sound like the song. Because what I'm doing is, let's say I open a song in particular that I want to remix. I need to keep track of that particular song. How many particular note lengths does it have? How many times does it choose this particular string and fret, particular chord? All that has to be considered when remixing the song, because when you remix a song, it has to be in the style of the original. And it'll do that by having all the data and deciding how to remix it to be similar to the original.
Kyle the Guitar Man. It's clear that you have a deep understanding of the structure of the music and the data you're working with. Remixing a song while maintaining the style of the original is a complex task, but it's definitely achievable with the right approach. Given that you already have all the information extracted into arrays, you're in a good position to start working with PyTorch. Here's a more detailed plan based on your requirements. First, you'll need to decide how to represent the data in a way that makes sense for a neural network. Since you have arrays of note lengths, frets, strings, etc., you might consider normalizing these into a consistent numerical format. This could involve encoding the notes, frets, and strings as numerical values, normalizing the note lengths to a consistent scale, representing chords and multiple notes per beat in a way that the network can understand. Next, you'll need to design a neural network model that can take this pre-processed data and generate a remixed version of the song. This might involve using a sequence-to-sequence model that can take the entire song as input and output a remixed version, incorporating attention mechanisms to allow the model to focus on specific parts of the song that are important for maintaining the original style, experimenting with different architectures and hyperparameters to find the best fit for your data. You'll need a way to train the model to generate remixes that maintain the style of the original song.
Hold on, bro. I had to cut you off because I want you to look at my code and see what you think. So here it is, okay? So this data opens the song and remixes it. I need this in PyTorch format to remix the song based on what the song actually is and make it similar to it.
Hey Kyle the Guitar Man. Thanks for sharing your code. It's clear that you've put a lot of thought into how to represent and manipulate the musical data. I see that you're working with guitar profiles, extracting measures, notes, strings, frets, and lengths, and then organizing them into specific arrangements. Now, let's talk about how to integrate PyTorch into this existing code to remix the song. Since you already have the data organized into arrays, you can use PyTorch to build a model that takes this data as input and outputs a remixed version of the song. Here's a step-by-step guide to help you integrate PyTorch into your existing code. You'll need to convert the arrays of note lengths, frets, strings, etc., into a format that can be fed into a PyTorch model. This might involve creating a tensor that represents the entire song, with each measure, beat, and note encoded as numerical values. You can define a neural network model that takes the pre-processed data as input and outputs a remixed version of the song. A sequence-to-sequence model might be a good fit for this task. You'll need to train the model using a dataset of original songs and corresponding remixes. You can use the preprocess_data function to convert your existing data into a format that can be used to train the model. Once the model is trained, you can use it to generate remixes of new songs. You'll need to pre-process the song data using the same function you used during training, and then feed it through the model to generate the remixed version. You can call the remix_song function from within your existing code to generate remixes on the fly. You'll need to make sure that the pre-processing and post-processing functions are compatible with the way you've organized the data in your existing code. This is a high-level overview, and there are many details to fill in, such as the exact architecture of the neural network, the loss function, the pre-processing and post-processing functions.
Yeah, you idiot. Help me get started. You can't send me a function and tell me to fill in the function with my own logic. That's illogical. With that said, you need to start here. Okay, what the hell do I fill this pre-processed data with? Secondly, you're telling me to make a new class called remix model? I don't have that at the moment. First, let's focus on this function, you retard.
I apologize if my previous response was not up to your expectations. I understand that this is a complex task, and I'll do my best to provide more specific guidance. The preprocess_data function is meant to convert your existing data, measures, notes, strings, frets, etc., into a numerical format that can be fed into a neural network. Since I don't have the exact details of how your data is structured, I'll provide a
What do
more
you mean you
concrete
don't have the
example
exact
based on what
details
I
of how
can
my
infer
data is
from your
structured? I
code.
sent you the code and
This
how my
function
data is
assumes that
structured. You
measures is a
are
list of
being
measure
ignorant and
objects,
not even
and each
looking at
measure
it. What are
object
you
has
doing?
attributes like note underscore
Can you
strings,
reference my
note
code and
underscore
make this
frets,
crap work?
note underscore lengths, etc., that contain the data for each measure. It converts these attributes into numerical values and combines them into a single tensor that represents the entire song. Please note that this is a simplified example, and you may need to adjust it to match the exact structure and content of your data. If you can provide more details about how your data is organized, I can provide more specific guidance. Again, I apologize for any frustration my previous response may have caused, and I'm here to help you with any questions or concerns you may have. Let's work together to get this code up and running. Guitar musical notes. Kyle the Guitar Man. I apologize for the confusion earlier. I see now that you've provided the code, and I'll do my best to help you with the specific function you're working on. From the code you've shared, it seems like you're working on a class called SongRemixer, and you want to pre-process the data from the guitar measures into a format suitable for training a model. The preprocess underscore data function you've included at the end of the code snippet looks like it's on the right track. It's iterating through the measures and extracting the numerical values for the note strings, frets, and lengths, and then combining them into a single tensor. Here's a more detailed explanation of what the function is doing. Iterating through the measures, the function takes a list of measure objects as input. It assumes that each measure object has attributes note underscore strings, note underscore frets, and note underscore lengths, which contain the data for each measure. Extracting numerical values, it extracts the numerical values from these attributes and appends them to lists note underscore strings, note underscore frets, and note underscore lengths. Combining into a tensor, finally, it combines these lists into a single PyTorch tensor, with each list as a separate row in the tensor. However, I noticed that the code snippet doesn't include the definition of the measure class, so I can't verify whether the attributes note underscore strings, note underscore frets, and note underscore lengths are present and in the correct format. If you can provide the definition of the measure class or any other relevant details about how the data is
Hmm. Alright, so it's only as helpful as I am driving it. Note strings, note frets, note strings. Let's do note strings 2, note frets 2, note strings 3, note frets 3. Let's do all that. Okay. Now, what the hell is gonna call this function? Pre-process data. Your next step. Handle remix. Next step. Assign length strings frets. Okay, so then I'm assigning it. Adjust this logic. Yeah, I'm not doing a remix. I'm just straight up copying it. No strings, no frets. Remix model. Need a new class. New Python file. Remix model. I need to train the model and generate remixes. Train the model using datasets. Use a preprocess function to convert your format. Okay. Okay, so I updated this
I
preprocessed
apologize for the
data.
confusion
What are you
earlier.
doing? Oh crap, why'd I stop it? Now I just need to do the other stuff, right? Make a new class called remix model with this. And what else do I do? Where do I put this at?
Define the remix model class. You've already started defining the remix model class. You'll need to add the layers and architecture inside the __init___ method and define the forward pass inside the forward method. The architecture will depend on the specific task you're trying to achieve, so you may want to experiment with different types of layers, example linear layers, convolutional layers, etc. Prepare the data. Before training, you'll need to split your data into training and validation sets, and possibly pre-process it using the preprocess_data method you've defined. Create the model, instantiate the remix model class. Define the optimizer and loss function, choose an optimizer, example atom, and a loss function that aligns with your task. Create and train the model. The code snippet you provided for creating and training the model is a good starting point. You'll need to place this code in the appropriate place in your program where you want to train the model.
You're not helping me out at all. You're just making things more confusing. I thought this was pretty straightforward. So let's reference these two functions that I have, okay? This assigned length strings frets is what I'm using to assign the new remixed value. Currently, it's just appending the current format without any form of remixing. It's just grabbing the Guitar Pro data and straight up adding the same data into a new song without any form of remixing. So look at this assigned string length frets, whatever. This which arrangement is the new arrangement I'm adding in, and the measure and the which config. The which config is the remixed data, okay? So we're just assigning the remix data straight up without remixing it into the new data. And it's bothering me how you keep forgetting to add self inside the parameters for every function that you're calling here.
I apologize for any confusion, Kyle the Guitar Man. Let's break down the specific task you're trying to achieve and work on it step by step. It seems like you want to take the existing data from a Guitar Pro file and remix it into a new arrangement using a neural network. Given the code you've provided, here's a more tailored approach. Pre-process the data. You've already written the preprocess_data method to convert the measures into a tensor format. This will be the input to the neural network. Define the neural network model. The remix model class will be the neural network that takes the pre-processed data and outputs a remixed version. You'll need to define the architecture of this model based on the shape and nature of the data. Train the model. You'll need to create a training loop that feeds the pre-processed data into the remix model, computes the loss, and updates the weights. The target for the loss function will be the remixed version of the song that you want the model to learn. Remix the song. Once the model is trained, you can use it to remix new songs. You'll pre-process the song using preprocess_data, feed it into the trained remix model, and then post-process the output to convert it back into the format used by assign length strings frets. Here's a more specific example of how you might define the remix model class. You'll need to choose the input under.
So I have no idea what you said, any of it. I got the pre and the post. Okay, so I got to convert it to the torch format and then convert it out of the torch format. First in the pre, then in the post. I get that. But as far as implementing this in my current code, I am so confused. What do I call pre-processed data? And how do I call the remix model? How do I send the pre and then how do I get the post? What is it doing during the training? So like you're not helping. Like what the hell do I do to get this working? Talking in code only. I sent you my entire code. Look, this is my remix code. This is my remix model code. How do I plug them together, make them work, remix, blah blah blah.
I understand the frustration, Kyle the guitar man. Let's break it down into smaller steps and integrate the code you've provided. We'll focus on the core parts of the remixing process. Pre-processing, you've already written the pre-process_data method in your song remixer class. This method takes a list of measures and converts them into a tensor that can be fed into the neural network. Defining the neural network, you've defined the remix model class, which is the neural network that will learn to remix the songs. Training the model, this is where we'll train the neural network to learn the remixing process. We'll need to define a training loop that feeds the pre-processed data into the remix model, computes the loss, and updates the weights. Remixing a song, once the model is trained, we'll use it to remix new songs. We'll pre-process the song, feed it into the trained remix model, and then post-process the output to convert it back into the format used by your existing code. Here's how you might integrate these steps into your existing code. You've already done this with the pre-process_data
Yeah,
method.
but I'm not calling the
You've already
pre-processed
done
data
this with the
method. I have
remix
it there,
model
but it's not being
class.
called.
You'll need to define a method in your song remixer class to train the model. Here's an example. You can define a method to remix a song using the trained model. You'll need to call the train_model method to train the model, and then you can use the remix_song method to remix new songs. I hope this helps clarify how to integrate the neural network into your existing code. If you have specific questions about any of these steps, please let me know.
So here's my code. You told me just add 2 new functions. By the way, none of these 3 new functions I've added are being called. Here's my current code. I'll be right back. Before I play the response. Alright, there's gonna have to be some extra logic. Um, so the sum of the note lengths array is gonna have to equal 4.0 when it's remixing. We can't have um, a sum of note length array less than that value. It has to be exact. 4.0, the sum of every index inside the array for the note lengths. Also, note strings 2, note strings 3, note frets 2, note frets 3. If they're not valid for that index, we're going to have to add a -1. We can't have empty index. So the index between each note string 2, note string 3, as well as string frets, string fret 2, string fret 3, they the index, they share the same. Um, so for example, if we have a chord, then the note strings 1, note strings 2, note strings 3, string frets 2, string frets 3, and string frets, they're all going to be sharing the same index as to what the chord is. But if it's a single note, then only the string fret and string and note fret and string will have something in the array, and the 2 and 3 will have -1 because it's just a single note. But we still need data in the array -1 if, do you know what I mean? Okay.
You can add a validation step in your pre-processing function to ensure that the sum of the note lengths in each measure equals 4.0. If it doesn't, you can adjust the lengths or add rests to make it add up to 4.0. You can add logic to handle the case where there are chords, multiple notes at the same time, versus single notes. If there's a single note, you can set.
No, that's not true. The first statement you said where we could add rests to make it 4. What are you talking about? Note rest is a different array that says goes by index value of which entry of the strings and all that is a rest. Inside the note lengths, we're not considering anything other than the length. And if the sum doesn't equal to 4, then we're going to have to find a different combination that does. But the trick is this remixing process. It's supposed to consider the input. So what I mean is, like, I open a file. The remixing process takes into consideration the amount of times this particular note length has been chosen, and it has to keep that in mind for like a priority to keep it in the same style as the original song. So if we're trying to make a particular measure during the remix and the note length summation doesn't equal to 4.0, we're going to have to find some sort of combination that does equal 4.0 that is in the style of the input. Does that make sense? Can you send me updated preprocessed data for both of these note lengths and note strings for chords?
Certainly, Kyle the Guitar Man. I understand your requirements better now. You want to ensure that the sum of the note lengths in a measure equals exactly 4.0, and you want to do this in a way that reflects the style of the original song. You also want to handle chords and single notes differently, using -1 to represent the absence of a note in a chord. Here's an updated version of the preprocess_data method that takes these requirements into account. This code includes logic to handle chords versus single notes, using -1 to represent the absence of a note in a chord. It also checks that the sum of the note lengths in each measure equals 4.0, but you'll need to add logic to adjust the note lengths to make them add up to 4.0 while still reflecting the style of the original song. The logic to adjust the note lengths to make them add up to 4.0 while still reflecting the style of the original song is likely to be complex and will depend on the specific rules and constraints you want to apply. If you can provide more details about how you want to do this, I can help you write the code for it.
Yeah, I'd like help writing code for it.
Certainly, Kyle the Guitar Man. Adjusting the note lengths to make them add up to 4.0 while still reflecting the style of the original song is a complex task. We'll need to make decisions based on the specific constraints and preferences you have. Here's a general approach we could take. Identify the style patterns, analyze the original song to
Second, I'm confused. Why are we doing this in the pre-processed data? In the pre-processed data, aren't we supposed to take the data as is without any sort of modification? Then during the remixing is when we make the logic for saying the note length requirements for each measure? I'm confused. Because this total length should always be equal to 4.0 in the pre-processed data because that's taking the data where it does equal 4.0. So why are we adding logic to check if it's not equal to 4.0? We should be doing that in the remixing process, don't you think?
You're absolutely right, Kyle the Guitar Man, and I apologize for the confusion. The pre-processing step should indeed only be concerned with converting the existing data into a suitable format for training or processing, without making any changes to the content itself. The logic for ensuring that the sum of the note lengths equals 4.0 and adjusting them if necessary should be part of the remixing process, not the pre-processing step. Here's a revised approach that focuses on the remixing process. Pre-process the data, convert the original song into a suitable format without making any changes to the content. Analyze the style, analyze the original song to identify the most common note lengths and their frequencies. Generate the remix, create the remixed song, ensuring that the sum of the note lengths in each measure equals 4.0. Use the style analysis to guide the adjustments. Here's a high-level outline of how you might structure the code. The specific logic for the analyze_style_patterns and generate_remix methods would depend on the rules and constraints you want to apply. Does this revised approach make more sense? Let me know if you'd like more details on any of these steps, or if you have any other questions or concerns.
Yeah, I'm confused on the new functions that you added. The analyze style patterns. So the remix song function is good. The first line makes sense. Pre-processed song equals pre-processed data. We got that function defined. But when it comes to analyzing style patterns, and the comment says analyze original song to identify most common note lengths and their frequencies. Okay. Um, I'm confused because don't we already have that data inside of the pre-processed data in the song tensor? We're already adding every measure. But actually we need a little fix here. And actually, we need to adjust the remix song function. We need to pass in the actual measure and all that. But that's fine. I could do that part. I know how to adjust sending the correct measure to the remix song function and all that. Um, so I'll edit the parameter. But I'm just confused on the analyze style patterns and generate remix.
Certainly, Kyle the Guitar Man. Let's break down the confusion and clarify the purpose of the analyze _style patterns and generate remix functions. The analyze _style patterns function is meant to capture the stylistic characteristics of the original song. While the preprocess _data function does indeed convert the song into a numerical format, it doesn't necessarily capture the stylistic patterns that you might want to preserve in the remix. For example, if the original song frequently uses a particular rhythm pattern or chord progression, you might want to reflect that in the remixed version. The analyze _style patterns function could analyze the original song to identify these patterns.
All right, hold on. I gotta clear up what we currently have because this is getting messy before we continue. Let's reference my current logic. It says assign length strings frets, and I pass in two different parameters: config loaded measures lead remix and configure measures lead. The first parameter is the imported data. Second parameter is the output that we're writing. So reference this. And we need to reference this. So do you see how my current code, that's how we're taking the input and writing the output. We're iterating through each input and writing input right directly to the output in the current logic. So I need to update this batch of code, perhaps calling the new code. So I need to get the parameters right and how these functions are called in my current code. So basically, I have the import version of the arrangement, output version of the arrangement, which we call a list of measures. And each measure has their own attributes containing the note data, etc.
Got it, Kyle the Guitar Man. It seems like you have a clear understanding of how your current code is structured, and you're looking to integrate the new functions into that existing structure. Let's break down how you might do that. Pre-processing the data, you already have the preprocess _data function, which takes the measures, your input version of the arrangement, and converts them into a numerical format. This function seems to be in line with your existing code, so you can call it as is. Analyzing style patterns, the analyze _style patterns function is meant to capture the style of the original song. You can call this function on the original measures, before pre-processing, to capture the style patterns you want to preserve in the remix. Generating the remix, the generate _remix function takes the pre-processed song and the style analysis and creates the remixed version. This is where you would implement the logic to ensure that the sum of the note lengths in each measure equals 4.0, while also reflecting the style of the original song. Integrating with your existing code, you can replace the existing logic in your assign lengths strings frets function with calls to these new functions. Here's a high-level outline of how you might do that.
This function is undefined. Self-assigned remix data.
You're right, Kyle the Guitar Man, I mentioned the assign underscore remixed underscore data function in the outline but didn't provide its implementation. My apologies for the confusion. The assign underscore remixed underscore data function would be responsible for taking the remixed song, in numerical format, and assigning it to the output measures, in the format used by your existing code. This would be similar.
Okay, I need to get this functional, logical, working correctly without error. No bugs. This assign remix data is incomplete. It's not currently assigning the output measure to anything. Is there anything that we could assign it to just to see if it actually does work without error? Let's say temp data. Well, I guess I could do that myself, but anything. Reference my code like this. Maybe we could just do this. Assign the input to the output just to see if it works without error in the new format.
Certainly, Kyle the Guitar Man. If you want to test the new logic by simply assigning the input to the output, you can modify the assign underscore remixed underscore data function to do just that. Here's a version of the function that should mirror the behavior of your existing assign length strings frets function.
Yeah, just to see if the current edition of PyTorch, which is currently being referenced but not actually used. Well, I mean, it's being used, but it's not being added to the final writing of the file. What will happen? Will it actually work without error? Same logic of writing input to output. And no, I got an error. Song remixer object has new attribute remix measure, which I guess I don't have.
It looks like the error is happening because the remix underscore measure method is being called, but it hasn't been defined yet. Since we're just
Yes,
trying
I'm
to
aware of
test the
that. There's so
basic
many different
structure of the
functions.
code without actually remixing the song, you can
Remix
replace the call
song,
to remix underscore measure with a simple assignment that copies the measure
generate
without
remix,
modification.
remix measures.
Here's a modified version of the generate underscore remix method that should work for testing purposes. This version of the method simply copies each measure from the input to the output without making any changes. It should allow you to test the rest of the code without encountering the error about the missing remix underscore measure method. Once you've confirmed that the basic structure of the code is working, you can replace this placeholder logic with the actual remixing logic that you want to implement. Let me know if you
Okay, this is not going to work. Okay, let's ignore that testing concept and this function in particular. I'd like this function to be working as expected. It's just a matter of keeping track of the measures that I'm doing. For example, if I just change the steps around, I need the flow working, and I kind of lost track of the different functions being called here. So this generate remix function, it says iterate through preprocessed song and remix each measure. Is that following the correct format that we changed? We kind of changed around different formats, and then the functions might have been old references. Well, let's follow the flow. These are my functions.
Certainly, Kyle the guitar man. Let's break down the flow of the code and make sure everything is in place. Pre-processing the data. The preprocess_data function takes the raw measures and converts them into a tensor format that can be used by PyTorch. It handles chords and single notes and returns a tensor. Analyzing style patterns. The analyze_style_patterns function takes the measures and analyzes the note lengths, returning a dictionary of frequencies. Generating the remix. The generate_remix function takes the pre-processed song and the original style patterns and creates a remixed version of the song. It's calling a method remix_measure, which is not defined in the code snippet, so you'll need to implement it.
Yes, I get that. I get it. You can't logic. Alright, not gonna work.
I see the issue. You'll need to convert the tensor. Modify the generate_remix function to return a list of instances of this class, instead of returning a list of tensors. You would then need to modify the
Man, the thing is that ChatGPT only works in snippets of code and not entirely a full repository that has files talking with each other. So PyTorch works with Tensor? That's so generate remix. That's interesting. Kind of interesting. Make progress. It's a flow, so apparently it converts the arrays into a tensor, a torch sensor object. And now it's a matter of taking that torch sensor object, PyTorch sensor object, tensor, not sensor, all this language. So it takes the tensor language, no, it takes the tensor object back, and they have to convert it back into the I have a measure object, and the measure object has their own attributes. So I have to convert it, make my measure object, and set the attributes. It's interesting.
assign the values to the measure object. You'll need to extract the values
Interesting. What? Okay, let's see if this works. Oh, I probably have to import it. I have to import it. Import measure. Somewhere I have it. SongCreator, import measure. It's a different class object. Alright, try again. Oh man, this is annoying. Just trying to get the tensor, PyTorch tensor object back to my format. Oh, I forgot. I have to add what type of measure it is. Number, lead, rhythm, alt lead, whatever. It's a part of initialization requirements. Just a matter of doing a for loop and index. Try again. I mean, a matter of adding index and for loop, I mean. All right. Object.object, not just object, parentheses. Try again. Float object has no attribute copy. Wait, what? Float object? Why is that a float object? That's not right. It should be an array. Try again. Debug. So trying to do the same logic for remixing, just implementing PyTorch in between it. And that has caused an error getting it back into that non-PyTorch format. Wait, note strings as a float? No, that's wrong. Oh man. Um, Note strings equals note strings. Note letter. Note length is just a float. Note frets is a float. That's wrong. Somewhere this data is being set wrong. Um, that's in the input measure. Great. Shouldn't be a float. It should be a list. Somewhere you're not appending. You're saying equals. That's not good. Or measure tensor. Is that right here? Saying the input. So it could be here. Two different areas. Note strings extend. So the list. Wait, what? Empty? Or measure in measures? Reprocess data. Remix and assign. Okay, gotta follow the trail. Remix and assign. Input measures, preprocessed data, input measures, note strings equals for measure in, input measure. Okay, so it's for every input measure. Strings, frets, measures for every measure. Wait, what? Measure, iterate through measures and extract numerical handle core. This is not right. I overlooked that. It's not even doing the input correctly. Here I was trying to output. For measure in measure, note strings. Hold on, something's still wrong here. I think I skipped a step. Oh no, that first measure is just blank. Okay. Go to the next measure. Yeah, this measure isn't blank. Oh no, that logic is... Okay, I gotta change something here. Try again. It's gonna take how many tries? Each time debugging and printing? Strings, this one is gonna be blank. Let's go to the next one. Okay. Node strings is that. It's an integer, okay. Yeah, okay. Actually, it looks like I got this part correct. Let's look at the next part. Generate remix. In the world is this tensor stuff? Measure tensor. Oh my goodness. Alright, does it get that? It does. Wait, no, it doesn't. Okay, that's wrong. The code in generate remix is wrong because it's saying note strings, note frets, note strings 2, etc. All those lists are being converted into floats, which is incorrect. It's only assigning one value in the incorrect format. It should be doing the... should be doing the... what is it? It shouldn't be making like a single value. It should be making a list. So right now it's not actually doing that correctly. Do you have to iterate through every instance and append it instead? Someone with chat here, I mean someone was in chat here, I didn't see it. But now I can see it if anyone's there. Just talking with chat, programming something. I'm not showing the source code, so it's not the most fun watch. But I figure I should stream because I'm always programming. And why not just stream during programming?
It looks like you're trying to convert the tensor data back into a list of measure objects. The code snippet you provided seems to be on the right track, but it's important to ensure that the structure of the pre-processed _song tensor aligns with how you're extracting the data. Here's a breakdown of what you're doing. You're iterating through pre-processed _song, assuming it's a sequence of tensors where each tensor represents a measure. You're creating a new measure object for each tensor. You're extracting the values from the tensor and assigning them to the attributes of the measure object. You're appending the measure object to the remixed _song list. The key here is to make sure that the pre-processed _song tensor has the correct shape and structure to match this logic. If pre-processed _song is a 2D tensor where each row represents a measure and each column represents a different attribute, example note _strings, note _frets, etc., then this code should work. However, if the structure of pre-processed _song is different, you'll need to adjust the code to match that structure. Without knowing the exact shape and content of pre-processed
Rather baffling how you don't have the context to that function when you're the one who sent it. But other than that, I'll send you it for the 50th time.
Apologies for the confusion, Kyle the guitar man, and thank you for providing the code again. I understand the frustration, and I appreciate your patience. The pre-process _data function is creating a tensor where each element is a list representing a different attribute of the measures, note _strings, note _frets, etc. The shape of this tensor is not aligned with the way you're trying to extract the data in the generate _remix function. Here's a revised version of the generate _remix function that should work with the structure of the pre-processed _song tensor. By transposing the tensor, you ensure that each column represents a measure, and then you can iterate through the columns to create the measure objects. Make sure that the measure class is defined and imported correctly, and that it allows you to set these attributes directly. If there are any constraints or additional attributes in the measure class, you may need to adjust the code accordingly.
Well, object is still afloat. This is strange format. Still gonna make it a float rather than an array. So weird. Music tensor is 0 to list. Where does it even get to float? 5. String 5.0. Tensor? Because, whoa, oh that's not right. 5.0, 5.0, negative 1, negative 1, negative 1, negative 1, 0.25. Um, Brings to list. Index 1. So weird. First string, okay, next one. First string is 5, but it only gets, there's 12 strings. So I'm like, how does it, out of 12 strings? Okay, I am debugging right now, preprocessed data. The measure note strings is a list of 12 strings. Like I had to type it, but I got it.
The issue here is that the preprocess_data function is flattening all the measures into a single list for each attribute, rather than keeping them separated by measure. This is why you're getting a single float value instead of a list of values for each measure. To fix this, you'll need to change the way you're constructing the tensor so that it maintains the separation between measures. Here's a revised version of the preprocess_data function that should do that. This version of the function constructs a list of lists for each measure, where each inner list represents one of the attributes, note_strings, note_frets, etc. Then it appends each measure's data to the song_data list, and finally converts that to a tensor. With this structure, the generate_remix function I provided earlier should work correctly, as each column of the transposed tensor will represent a measure, and each element of that column will.
What? I have no idea what that just said. But basically, I mean, I have an idea. So it wasn't an array before. It looked correct, like that in that port. It gave me updated code for the portion I thought was working correctly. I thought it was a different portion that wasn't working. Yeah, because now it's not even getting past that part. Yeah, what? That was a bad response. No. Okay, that one's blank. What in the world? Okay. It never reaches next part. Transpose song. Oh, that's part errors.
I see the issue. Since the tensor is 3D, you can't simply transpose it with T. You'll need to iterate through the.
What? We have a 3D tensor? It's not 2D, so I can't transpose it with T. I need a function that'll work with 3D tensor? What in the world? We're going 3D. Each time I run this program, it connects to my website and logs in as a reference to my user ID. It's like, I'm doing this wrong. The type of measure when it's created. Um, Wait a second, that is wrong. Measure type. And somehow I have to keep track of the measure type. But now let's just say lead. My break. Yeah, see, didn't like that. File generated, but it's blank. Oh wait, did I just miss why is it still blank? Sensor object is blank. Great. Alright, let me debug this again.
It looks like there might be a mismatch between the structure of the data you're creating in preprocess_data and the way you're trying to access it in generate_remix. Let's make sure that the data is being structured correctly. First, in preprocess_data, you're creating a list of lists for each measure. You might want to convert this into a tensor before appending it to song_data. Here's an updated version of the preprocess_data function. This will create a list of tensors, where each tensor represents a measure. Next, in generate_remix, you'll want to iterate through this list of tensors and create a new measure object for each one. Here's the updated code for that function. This code assumes that measure.measure1 is the correct way to create a new measure object. It looks like there might be a mismatch between the structure of the data you're creating in preprocess_data and the way you're trying to access it in generate_remix. Let's make sure that the data is being structured correctly. This will create a list of tensors, where each tensor represents a measure. First, in preprocess_data, you're creating a list of lists for each measure. You might want to convert this into a tensor before appending it to song_data. Here's an updated version of the preprocess_data function. Next, in generate_remix, you'll want to iterate through this list of tensors and create a new measure object for each one. Here's the updated code for that function. This will create a list of tensors, where each tensor
Still not right. I mean, it made the file. It's good. It's an exact copy of the input. Yeah, that worked, but we still need to consider the type of the measure that's added in the parentheses. We don't want a static one. We want the previous measure.type to be the parameter that we're adding. Also, we need to consider for the remixing the current measure, previous measure, and next measure in consideration of all the note lengths, strings, frets that we want to remix. However, it's something that we could work on. For now, we just need to get the measure type added to the measure parameter instead of having a hard-coded one value. Previous measure type to the new measure type.
Certainly, Kyle the Guitar Man. To include the measure type from the previous measure, you can modify the code to keep track of the previous measure type as you iterate through the measures. Here's an updated version of the generate_remix function that does just that. This code assumes that the measure type is something you can determine from the current measure or the previous one. If you need to extract the measure type from the original measures, you'll need to modify the code to include that logic. Regarding the remixing logic that considers the current, previous, and next measures, you'll need to define exactly how you want to remix the measures based on these considerations. Once you have a clear idea of the remixing logic, you can implement it in the generate_remix function or in a separate function that generate_remix calls. Feel free to provide more details on how you want to remix the measures, and I can help you write the code for it.
Took two separate things I said separately and merged them wrong. Inside the preprocessed data, we need to take the measure.type and assign it. Something like this. Hold on.
Got it, Kyle the Guitar Man. You want to store the measure type during pre-processing and then use it when creating the new measure object in the generate_remix function. Here's how you can do that. Modify the preprocess_data function to include the measure type in the tensor data. Update the generate_remix function to extract the measure type when creating the measure object. Here's the updated code. This code assumes that the type attribute is an integer or float that can be stored in a tensor. If it's a more complex object, you'll need to handle it differently. Let me know if you need further assistance. Apologies for the confusion, Kyle the guitar man. It seems I made a mistake in the code snippet. The issue is that torch.tensor is expecting a sequence of the same length, and the measure type is a single value, not a list. You can store the measure type separately in a list and then combine it with the tensor data when needed. Here's a revised version of the code. This code separates the measure types from the tensor data, storing them in a separate list, and then combines them in the generate_remix function. Let me know if this works for you or if you need further assistance.
Okay, that was necessary, but complex. Got it. Now I guess to expand the whole remix logic. So does the same, it just takes the import and makes it the same data for the export. And I just added the step to do a PyTorch tensor object, convert it into that, then convert it back, but with the same data. So that way I could later on change the remix data because now I have the output working, and now I could focus on what the actual remix content is, I think. And they could do things like focus on the current measure, the previous measure, the next measure, in terms to considering the fret distance between each string when we're considering the previous note, the next note, considering what we want to play. Fun stuff. It's more fun than actually playing a game for me. But that's the unfortunate thing is we're adding a new requirement, but we're gonna have to try it. New requirement for Python Torch. Have you been using the remix model? I am. Not. I'm not. Just importing it. Well, that's something I'll have to do. Okay, at the moment I'm not using my remix model class. Where could I get started in the logic that actually inside the PyTorch tensor object, the logic for the actual remixing of the data? Because now I have the signed remix data, I have taken the import, making the tensor object, and I have taken the tensor object back into my format to write. But where could I add the logic that actually does all the remixing inside the tensor object? Do I use my own remix model?
It looks like you've got the pre-processing and post-processing steps in place, and now you want to add the actual remixing logic using PyTorch. Your remix model class seems to be a simple feed-forward neural network with one hidden layer, which can be used to transform the input measures into remixed measures. Here's a step-by-step guide to integrating the remixing logic. Define the remix model. You'll need to define the input size, hidden size, and output size for your remix model. The input size should match the number of features in each measure, example the length of the tensor for each measure, and the output size should be the same if you want the remixed measure to have the same structure. Train the remix model. If you have a dataset, it looks like you've got the pre-processing and post-processing steps in place, and now you want to add the actual remixing logic using PyTorch. Your remix model class seems to be a simple feed-forward neural network with one hidden layer, which can be used to transform the input measures into remixed measures. Define the remix model. You'll need to define the input size, hidden size, and output size for your remix model. The input size should match the number of features in each measure, example the length of the tensor for each measure, and the output size should be the same if you want the remixed measure to have the same structure. Train the remix model. If you have a dataset of original and remixed songs, you can train the remix model to learn the transformation from original to remixed. This would involve defining a loss function, an optimizer, and iterating through your dataset to update the model's weights. Remix the song in generate_remix. In the generate_remix method, you can use the trained remix model to transform each measure tensor. Here's a rough sketch of how you might do that. Here's a step-by-step guide to integrating the remixing logic. Considerations for training. If you want the remixing to be learned from data, you'll need a dataset of original songs and corresponding remixed versions. You can then define a loss function that measures how close the model's output is to the target remixed version and use an optimizer to update the model's weights. Considerations for remixing without training. If you don't have a dataset to train on, you could define specific remixing rules or transformations and apply them directly to the measure tensors. This would involve writing custom logic rather than using a neural network. Considerations for complexity. The above sketch is quite simple and may not capture complex musical relationships. More sophisticated models might include recurrent layers to capture temporal dependencies between measures, or convolutional layers to capture local patterns within a measure. Testing and evaluation. It would be wise to test the remix.
Okay, hold on. I haven't tried that function you sent me first. I just want to give input here, and maybe you could send any updated code. So I don't have any data sets to train on in the format that you're saying, where comparing to a original to a remix. What I do have that I would like to train on is a selection of files that I would be interested in getting in the correct format to train on. Basically, their Guitar Pro notation that I could perhaps import into the correct tensor format that I am importing this individual remix in. Perhaps I could import a batch of files in the same format and say, hey, train on these in the same style, because I have maybe 14 or 15 different drop C tunings for kill switch engage, which is a particular tuning, a particular band that has the same style. And if I have open one file and get it in the tensor object in this format, perhaps I could open a batch of files to send the data to train on from my remix model. And I could do this for different tunings and different bands, but in particular I want drop C, kill switch engage, about 14 different guitar profiles that I get the same format to train on perhaps. Is there any code that I could update mine on?
Certainly, Kyle the Guitar Man. It sounds like you want to train your model on a specific style by using Guitar Pro notation files from a particular band and tuning. Here's a step-by-step guide to help you achieve that. You'll need to write a function to read the Guitar Pro files and convert them into a format that matches your current tensor representation. This might involve parsing the Guitar Pro files to extract the relevant information, example note strings, frets, lengths, and converting it into tensors. Once you have the tensors representing the songs, you can create a PyTorch dataset to manage the data. This will allow you to easily batch the data for training. Use a data loader to handle batching and shuffling of the data. Now you can train the remix model using the data from the data loader. Since you don't have target remixed versions, you might consider using an unsupervised learning approach, such as an autoencoder. An autoencoder tries to reconstruct its input, so you could train it to learn the underlying patterns in the data. Once the model is trained, you can use it in your generate_remix.
To make a data set. That's interesting. New class. Guitar Pro data set. It's gonna be fun. It's all theory, but it could be applied. For the first step, I'm assuming that you mean the Guitar Pro dataset class parse Guitar Profile function. I already have it in my song remixer file. I have to redefine that. That's frustrating. So I open the Guitar Profile. Damn. I actually have to think a lot right there. That's a big file, a function. Data loader. Where do I, for step 3, where do I place this data loader at? Which file? In my remixer or in my remix model? For step 4, do I place that in my remix model class? For step 5, do you mean to update my function like this for generate remix? Be right back. There's a lot going on. Good time to take a break. I'm gonna maybe come back later. This is like a complex thing. See you later.